Okay, so let's take a look at some orbital diagrams. What orbital diagrams do is they show exactly where electrons live within sublevels and also what direction they're going to be spinning, either clockwise or counterclockwise. Now, orbital diagrams are going to be the thing that you have to be able to do first is do an electron configuration, and then we do an orbital diagram based off of that. So, first of all, you draw out your electron configuration, then you simply draw the orbitals. Remember that orbitals are pairs of electrons. So if we look at sublevel S, there's two columns, that is one pair. So there's only one orbital in S. P has 3 orbitals, D has 5, and F has 7 orbitals total. Then you add your arrows. Now, as we fill the arrows, make sure that you fill each individual orbital and then you pair up the electrons. Remember also that electrons will be going, first of all, clockwise for our purposes, but actually they could go either clockwise or counterclockwise first. The complement to that would have to go the opposite spin. That's called the Pauli exclusion principle, where electrons cannot fill the exact same space if they're going the exact same spin. So one will go clockwise, one will go counterclockwise, and just for our purposes in class, to make things a little bit more consistent for everybody, we're going to say that all the electrons will start going clockwise, even though that's not true. So let's take a look at some examples of how to do orbital diagrams. We're going to start with element number 18, argon. Now, as I said, we have to start with an electron configuration, so let's do an electron configuration for argon. 1s2, 2s2, 2p6, 3s2, 3p6. Now, if you have troubles with electron configurations and all that, take a look at the tutorials for writing electron configurations. Now what I do directly below my electron configuration is I draw in my orbitals. S has 1 orbital, so I'm just going to label that 1s. Energy level 2, sublevel S, there's 1 orbital there. That's a 2s. Now as I take a look at energy level 2, sublevel P, P has 6 total columns, that's 3 pairs, so that's 3 orbitals. 2p, and 3s now, I have 1 orbital in S. So you'll notice it doesn't matter if I'm energy level 1, 2, or 3, it's sublevel S has only one orbital. Now I add in my last one, the 3p. Notice I haven't done anything with electrons yet, I've just drawn the orbitals. Now I want to go through and I want to add in my electrons. So energy level 1s, there's 1 electron and 2. Energy level 2, sublevel S, 1 and 2. Energy level 2, sublevel P. Watch how I label these, or fill in these electrons. I fill orbitals first with 1 electron, then they pair up. They must go the opposite direction. Energy level 3s, and then 3p6, 1, 2, 3, 4, 5, and 6. Pauli exclusion principle states that you can't fill those going the same direction. Okay, so that's an orbital diagram. Let's take a look now at xenon. Xenon is element number 54, and this is going to be a long one, so I'll basically just start right up here. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, be careful, 3d10, 4p6. We're building up to xenon. We're at krypton right now. So we go 5s2, 4d10, and then 5p6. The only reason I picked this example is so you could see other sublevels. So energy level 1, S 1, 2, 3 is P, S 1, 2, 3, and P. I'm going to label that because my numbers are going to start running into each other. Here's 4s. Now 3d. 1, 2, 3, 4, 5. Keep them linear. We don't want to stack them or save space. This is going to stretch out and take a lot of space. So here's my 4p, 5s, 4d. Now remember 1, 2, 3, 4, 5. 4 Ds, and then lastly my 5p. Okay, I'll fill in my electrons. Basically these are all filled, so look at my D's. 1, 2, 3, 4, 5. Then they'll pair up 6, 7, 8, 9, and 10. And then 1, 2, 3, 4, 5, and 6. Okay. Same thing holds true with the F's and everything else. So pretty simple, pretty straightforward. There are exceptions to this. Now, basically what we went through in class is the D's and F's, if we can half fill those. Okay, so here's D, 1, 2, 3, 4, 5. If I have 1, 2, 3, 4 electrons, boy, this would be a lot more stable. If I say this is a 5D, this would be a 6S here. Normally, you would fill the 6S completely before you fill the 5D. What's going to happen is it's going to actually steal an electron from the 6S. It's going to half fill the 6S and take that other electron and put it into 5D to half fill the D. It'll be the same thing with completely filling. So if it's a 5D4 or a 5D9, that entire column, so we're talking columns 11 and column 7, those are stealing columns. Similarly, that's going to happen with the Fs. Remember, lanthanum starts 1, cerium is 2, 3, 4, 5, and 6, which is samarium and plutonium. That's 1 shy of half, so it'll steal. And thulium and mendelevium, elements 89 and 101, those are 1 shy of full, so they're going to steal. So copper, an illustration there, copper is element number 29. So we would have, let's see here, we would have 4s2, 3d9. I draw my orbitals, 1 and 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we're 1 shy of full, and full is the most stable. So we want to steal one of these S's, put it over here to completely fill the D. We're half filling S, so that's pretty stable, and we're completely filling the D, so life is good. We're completely stable with that. Now, what we will be doing with that, from that, is then going forward and doing quantum numbers. Now, quantum numbers is an address. The first number in the address is going to be what energy level an electron lives in. The second number in the address would be the sublevel. Now, for that, we have a little code. The code is, if it's an S sublevel, we would assign it a value of 0, P is a value of 1, D is 2, and F is 3. Then we number the orbitals. Keep in mind when we're drawing out our orbital diagram first, then we're assigning the middle orbital as 0, work out to the right, then to the left side, and I'll show you what that looks like. The fourth number is the spin. It's either going to be going clockwise, which is a positive 1/2, or a negative 1/2. Okay, so let's take a look at an example of cobalt. Okay, now cobalt is element number 27. So the first step is to do an electron configuration for cobalt. Element 27, here we go. 1s2, 2s2, 2p6, 3s2. Okay, that brings you out to magnesium. 3p6, 4s2, 3d, and that would be 1, 2, 3, 4, 5, 6, 7. That's not in a column that steals. I always have to double check that now. That's not a column that steals. It doesn't gain anything by doing that. So I can move on to the next step. The next step is going to be my sublevels. Here's 1s, here's 2s, here's 2p, 1, 2, 3 sublevels, or orbitals. Here's 3s, 1, 2, 3 for 3p, 4s, 1 orbital, and now I have my 3d, which is 1, 2, 3, 4, 5 orbitals. We fill in our electrons just like always. These are full, 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 full. 4s is full. Now I have 7 electrons. Be careful. 1, 2, 3, 4, 5. Then they pair up, 6 and 7. Let's describe this last electron right here. I just lost my screen. That's not good. Okay, so we keep on going from that. Sorry about that. I had a malfunction on the board. We're going to describe the 7th electron in energy level 3, sublevel D. Okay, so what we need to do is we need to describe the second one that's going down. It is a counterclockwise. Okay, the first one is going up. So we need to number now. The first number in a quantum number is its energy level. We're in energy level 3. The second number that I give is its sublevel. Now remember our code, that electron that I wanted to describe was in sublevel D, so I give it a number of 2. The third number that I give is the orbital number. So I have to go to the middle of the orbitals and I number it 0, 1, and 2, -1, -2. So from that, I can see that my D, my seventh electron in the D would be in the -1 orbital. And I see that it is going counterclockwise, it's going down, so we assign it a -1/2 value. There is my quantum set for that number. Okay, if we take a look at another example, I'm going to come up with the example. If I just erase this a little bit, give me some working room. Let's take a look at an example within an F. Okay, so let's take element number 92, uranium. Okay, so we go through our electron configuration just like always. I'm going to abbreviate it a little bit for the sake of time. 7s2. My F's are 2 less than the energy level, so that's 5F. And if I count in, make sure you count in actinium, that's 1, 2, 3, and 4. Double check, it's not one that steals, so we're good to go there. So here's my 7s, and I go through and go 1, 2, 3, 4, 5, 6, 7 orbitals for energy level 5, sublevel F. I have 4 electrons, 1, 2, 3, and 4. So now I want to come up with a quantum number. First number is 5 for energy level. So energy level 5. It lives in the F sublevel. So F would be a 3 value. I need to number my orbitals, starting with in the middle is 0, 1, 2, and 3, -1, -2, -3, and that last electron lives in the 0 orbital, and it's going clockwise. It's going up in this case, so we go +1/2. Just a note if you have an S sublevel that the electron is living in. So if I described that first electron in 7s, this is a 0 number for its orbital. So we would go 7, 0, and orbital number 0. The reason the first 0 is because S's are 0. Second 0 is because it's the 0 orbital. And if I'm describing the second one, that's a -1/2. Now, let's do the opposite. We'll just do one quick example of an opposite where I'm going to give you a quantum number and you have to tell me what element or what electron I'm describing. So I'm just going to make something up. Hopefully it works out pretty well. We're going to go 5, 2, -1, -1/2. Okay, so this is giving an example of the quantum numbers. You have to tell me what the electron is. So first number tells me energy level 5. The 2 value here tells me that I'm looking at a D, so 5D something. Now here's the key. You have to, as soon as you know it's D, draw out your orbitals, number them. Now I'm going to add electrons until the -1 orbital receives a negative spin. So 1, 2, 3, 4, 5. 6, and 7, 5d7. So then I just look on my periodic table. You find 5d in the 6th energy level. 5d starts with lutetium, so that's element number 71 is 1, 2, 3, 4, 5, 6, and 7. That's element 77, iridium. Atomic number 77. Okay, so keep that in mind. You do the first 2 things. You figure out what energy level and what orbital number it is, and then you have to draw it out, and then fill in your electrons until that orbital number receives that type of spin, whatever type of spin it needs, either +1/2 or -1/2.